All right, let's go. Class?
Yes.
All right, so we're continuing here. This is going to be the last unit before the end of the semester. Semester is about 3.5 weeks away. That's it. Christmas break, right? We are now out of the pumpkin spice season. Okay, it's no longer pumpkin spice seasoning. We're breaking into minter. Just so you know, it's minter. Everything's everyone's peppermint, right? Now it's minter. In the box. Here. So there we go. So what page are we in the notebook?
35.
35. Thank you very much. And I know no one has their earbuds in because everyone's paying attention right now, right? Because I got everyone, including Michael's, full and undivided attention because I know that's not earbuds in his ears.
Indeed.
So, objectives, all this other stuff. Now, if you think of it like this, okay, these things are puzzles. Don't think of it as much as a math problem as a puzzle. It's problem solving. It's less numerical computation and more of figuring out the pathways that we're dealing with here. So this is probably going to be one of the most applicable things that you're going to do in your life because this might actually affect you directly in your life's, your job, your career field. So let's say, for instance, okay, you're delivering pizzas. You need to know how to do the maps, okay, delivering pizzas. If that's where you're going to be for the rest of your life, that's going to be 1d6. So a graph consists of a finite set of points. Now, what does the word finite mean? Little, kind of. Limited. Limited. Yeah, you have the idea. So it's limited because it's the opposite of infinite. Infinite means it goes on forever, right? To infinity
and beyond.
Thank you. So finite means it is a limited amount of options or limited amount of points. So a graph consists of a finite set of points called vertices. So each one of the points is called a vertice. It's not referred to as a point, it's called a vertice. So every time I look at this point, you know it's a vertice. So, right? Yes, vertice? Good. Okay. Singular is vertex. A line segment or curves are also called the edges. So the sticks in between the dots are called edges. They are the edges that connect our
vertices.
Thank you. For all you people following along online and this video, I'm actually pointing at the words and everyone's supposed to be saying it. So if you can't hear anyone, everyone's sitting there and not paying attention. So let's try again. So these lines that connect the points are called edges. And the edges are referred to, wait, no. Man, I just screwed that one up, didn't I? Okay, so, and all these points are referred to as?
Vertices.
Thank you, good. Anyway, so an edge that starts and ends at the same vertex is called a, here's an example of a loop right here. So it starts and ends on the same place. Yes? Good.
Right.
Explain why the figure below show equivalent graphs. These are going to be equivalent to each other because we're starting at A. This one over here is starting at
A.
All right. This one, I can only go one direction. So starting at A, I have to go to what?
B.
I go to B. And after B,
C.
goes to C. And from C, there we go. So this goes A to B to C to D. All right, now let's go look at this other one. And this one right here goes from A to B to C to D. So they are equivalent because they are the same pathway, just going, I don't know, I make it a little bit more complicated. Does that make sense or nonsense? All right, good. Okay, so let's go ahead and take a look at this next one here. All right, Okay, so early 1700s, city of Kronenberg, located both banks, two islands of the Pringle River. The figure below shows that town sections were connected by 7 bridges. Draw a graph that models the layout of Kronenberg. Use vertices to represent landmass, edges to represent. Now, this is actually where graph theory came from in the first place. Hey, do you mind? Pay attention up here. It's all about me right now. Come on. Anyway, all right, so right here, this is the 7 bridges. So we have the left bank, it's going to be this dot right here, and I have 2 bridges from left bank to the island, and that's where I go from the left bank to the island. There's 2 separate bridges, so I'm showing those in 2 distinct different pathways. Right? Right here. It would help if your notes are open. Are you on the right page?
Yes.
You sure? Okay, good. Stare at the notes. Stare at the notes, not her. How dare you? So, from A to the right bank, how many bridges do I have? 2. So I have 2 distinct pathways to go from A to R. And then, how many pathways? I only have 1 pathway to go from R down to B, right?
Yeah.
So from R down to B, I have 1 pathway there, right?
Yeah.
Because there's only 1 bridge connecting those. And from A to B, again, 1 bridge connecting those.
Yeah.
Does that make sense?
Yeah.
Nonsense? Amanda? You alright? Okay. Alright, and from L to B. Just 1 bridge connecting. So now, by removing the I don't know, what are you for Google Maps, what's that, like satellite view? Yeah, remove satellite view, then you're left with just this, where it shows me going from point to point that I have 2 different roads to go from L to A. And I have 2 that goes from A to R, and in between. You can actually see all of them there if I remove all the satellite view from Google Maps, right?
Right.
Does that make sense?
Yeah.
Okay, so now what we've done is we're using this to try and make these. Now the next one right here, we are going to do the same thing for this. It says the map of New England states are given below. Draw a graph that models which New England states share a common border. Use vertices to represent the states and edges to represent common borders. So let's go through on the next one and let's out. So up here I have, I think this is Maine, ME.
Yeah.
All right, and over here is, what's that? New Hampshire?
Yeah, New
And
Hampshire.
then on the left is Vermont.
This is VT.
Yeah, Vermont.
Yeah.
All right, down here is
Massachusetts.
MA.
Yeah, everything.
And then below Massachusetts I have,
Rhode Island.
I believe it's like Connecticut.
Yeah, Connecticut and then Rhode Island.
And then Rhode Island, right?
Yeah.
Something like that, right?
Yeah.
Okay.
Amazing job.
I know that, yeah. I bet you before this day here, if we asked you to put these states on a map, half of you would not be able to pick them out.
I would, I was just doing that. That's how I
Oh,
knew-
really?
That's how I knew New Hampshire.
Oh, okay. So, people in my last class, they said the same thing. They're like, man, I totally forgot some of these states exist. All right, and now we're going to talk about the edges. We're going to do the edges in between. So now just looking at the edges. So from Maine, if I leave Maine, what's the states I can go to? New Hampshire. Can I, if I leave Maine, can I go to anything else? No. Why?
Because you have to cross the
Because you have to get through.
You have to go through New Hampshire first before you can go through anything else, right? So I'm going to start with Maine, and I can only go to New Hampshire. Does that make sense?
Yes.
Yes.
Huh? Maine of A?
Can we list Maine as A?
No. No.
What did he ask?
Just put ME.
Oh yeah, but like, no restart.
I'm so.
We're going to start there.
The labels not matter.
The labels do matter because they're the state, and we're talking about the states. And the states we're getting from here.
Oh, okay. Okay.
So yeah, that's why I'm using these. All right, what about New Hampshire? So from New Hampshire, what states can I go to?
Massachusetts.
We go to Vermont or
I can go to Vermont, right? Because that's touching New Hampshire.
yeah, and then you go to Massachusetts.
And can I go to Massachusetts?
Yes.
Okay. So let's see. So from right there, from New Hampshire, it's going to Maine,
Yeah.
it's going to Vermont, and it's going to Massachusetts.
Right.
Anything else?
No.
Nope. There we go. Now, what about Vermont?
You go to New Hampshire.
You only go to New Hampshire.
New Hampshire
You go to
and
Massachusetts. You go to
You
Massachusetts.
can go to New Hampshire,
You go to Massachusetts.
Massachusetts, and the ME. I don't know what the ME is.
Yeah, that's how you go to.
Then you can go to the ME as well.
can you?
Yeah.
You can go where?
Can you?
Oh no! It's my paper. It says different.
It says different.
Yeah.
No, it don't.
All right. You almost got me there. You almost got me. Anyway, all right. So where are we at now? So we did Vermont. Now time for Massachusetts, right?
Yeah.
So from Massachusetts, I can go to.
Rhode Island. You go everywhere except for Maine.
I can go Irvine.
Yeah.
Irware.
Yeah.
Okay, so look, so Massachusetts, I go to New Hampshire, Vermont, Connecticut, and Rhode Island. All right, so anything else I'm missing?
Rhode Island.
Connecticut to Rhode Island.
Connecticut to Rhode Island.
Rhode Island to Connecticut.
There we go. Right there.
Whoa.
So that's how they're. Yeah, go ahead. That's how they're all connected. I got. Now, what are these lines called? These are referred to as
Edges.
edges. Very good. So those are the edges going between there. Now, let's take a look at some of the vocabulary. The degree of a vertex is the number of edges at that vertex. Now let's go back and see what the degree is for each one. So, at Maine, what is the degree at Maine? 1, because it only has one edge, right? Let me change colors here, because, there we go. All right. All right, what about New Hampshire? What is the degree at New Hampshire? 3. 1, I go to Maine, I go to Vermont, and I go to Massachusetts. That's 3. What about Vermont? What's the degree?
2.
Massachusetts, what's my degree?
4.
Very good, I got 4. Connecticut,
2.
2, and Rhode Island.
2.
Does that make sense?
Yeah.
Yeah.
Angel, why don't you have the notes?
I don't know where they're at. I got you.
See? Make sure you have it. So, if you come in late, make sure they're all always right there. All right, make sense?
Yes.
A vertex will have an even number of edges attached to it is an even vertex. What are even numbers?
Like
2, 4, 6, 8, 10. Hey, I'm serious. Someone earlier today could not tell me what an odd number was. So that's why I am putting it on record. It's going to be on the YouTube of what they are. So if those are even numbers, odd numbers would be
1, 3, 5, 7, 9.
yeah, 1, 3, 5, 7, 9, right?
What is 0?
It's neither odd nor even.
Odd is wouldn't odd? No, I mean I ain't trying to.
Okay. If anything, it would be an even number
Yeah.
because you could distribute 0 evenly to everyone.
Yep.
All right. So this next one. 2 vertices in a graph that are said to be adjacent vertices if there are at least one edge connecting them. Adjacent vertices, one edge connecting them. Okay.
Would that be like ND?
Okay. What is adjacent to not Massachusetts,
Oh wait, I'm so dumb. I'm so dumb.
yeah, what's adjacent to Maine?
North Hampshire.
New Hampshire, that's it, right? So that's what adjacent means. All right, let's go through, and I have another example for it too. So let's start off with right here at letra A. Now, at letra A, see what I did there? My yo español, letra A. What is adjacent to A? B,
Isn't all of them?
C,
It's all of them.
D, and
E.
so we're listing them as adjacent because there is an edge connecting those, right?
Yeah.
Okay, good. Tricia, are you paying attention over here? Okay. How about B? Let's look at B.
C and A.
It's just going to be A and
C.
B, it's gonna be A, C, yeah. That's three then.
letter C.
A and B.
A, B.
A and B. I'll give you a second to write these down.
You gonna go over what E is, right?
I will. We're trying to go in alphabetical order here.
It's just really broad.
Oh, okay. D.
A.
Only A?
Yeah.
Only A.
Wait.
E?
Just want to see. See what I did there? See what I did there?
Only A,
No.
only
No, Mom.
And pay
E.
A.
And E, 'cause it's
And
going-
what?
E, because it's going into itself.
Very good. E.
Wait, what?
What is this thing called?
Oh, the loop, it's a circle.
It's a loop. So it connects to itself. So that is a loop, so it's going to be A and E on that one.
I'll be honest, I guessed on that. I didn't know. I didn't
Hey,
know.
it's almost like it was a vocabulary word like 5 minutes ago.
I didn't know that was a vocab.
You clearly
Oh, I
said
did not know that was a vocab.
wow. Huston.
We have vocab at first.
That's crazy.
Wow.
Dude, what are you smoking? Seriously, we just 10-second Tom. Seriously, come on, you like totally forgot it and we just went over it.
What happened?
See, that's your brain on TikTok.
I wouldn't be surprised.
Anyway. All right, does that make sense, you guys?
Yeah.
Are we good? So this is what I'm gonna do. I'm gonna stop right here. We're gonna, huh?
Homework?
Yes, we're gonna go over some of the homework. And so make sure you guys all like, share, and subscribe. Hit that notification button and support my channel. Buy some merch from my merch store.